Hey guys, it's gonna be a good one today. We're talking about cube roots. Okay, so we've been talking about square roots. Like that's what we have been talking about, square roots, and that led us into a conversation about imaginary numbers. But square roots in general, we said the square root of a number, right, is what number times itself makes this, right? So again, we said what's the square root of 81? And we said the square of 81 could be positive 9 or it could be negative 9, right? In other words, negative 9 times negative 9 makes 81, and positive 9 times positive 9 makes 81, right? There are two different answers for these problems, okay? And why essentially we call it a square root is that if I took a square and I said, hey, the area is 81, how long are the sides? Well, you know that 9 times 9 makes 81. What we're talking about today are cube roots, okay? Now, these are also a type of radical, but we're going to call them cube roots, okay? And the difference is that the cube root has a little 3 here. Now, sometimes for square roots, they'll put a little 2 here. I know on the iPhone calculator, I believe there's a little 2 there. I don't have an iPhone, so I don't know. I want to say that my calculator that might have it too. But for cube roots, if you see a little 3 there, it's the same concept, except they want to know something like this, okay? If you had a cube, I remember cubes back from geometry, right? They were like 3D squares, right? Where all of your edges were the same length, right? And they said, what if the volume is equal to 27? Well, we know that some number, length times width times height, right, and it's all the same, right, because it's a cube, will equal this. So what number times itself 3 times, okay? So if I said, what's the cube root of 27? The cube root of 27 would be 3, because 3 times 3 times 3 is 27, right? 3 times 3 is 9. 9 times 3 is 27. Important, though, not negative 3. Definitely not negative 3, because if we think about it, negative 3 times negative 3 times negative 3 actually makes negative 27. Okay, so we'll get to that in a little bit. That's second. I just want to get solid down what a cube root is, and we'll talk about this in a moment. All right. So let's go over some common roots. The thing is, because you're multiplying a number by itself 3 times, cube roots tend to get real big real fast. Okay. So let's say this. We'll say 0 to the 3rd power is 0. So what do I know? The cube root of 0 is 0. That has not changed. 1 to the 3rd power is 1. So I would say the cube root of 1 is still 1. That's still good news for us. 2 to the 3rd power is not 6, it's not 9, it is 8. This is the most common one we see. It's the most common one people get wrong, okay? So if I said, hey, what's the cube root of 8? You would say 2, right? Because what number times itself 3 times makes 8. 2 times 2 is 4, 4 times 2 is 8. 3 to the 3rd, 4 to the 3rd, 5 to the 3rd. So that would be 27, 64, and 5 to the 3rd is 125. So if you see real quick, these numbers are growing real fast. Okay, so if I said what is the cube root of 27, you would tell me 3. If I said what is the cube root of 64, you would tell me 4. And if I would say what is the cube root of 125, you would say 5. Again, in between a lot of these numbers, a lot of irrational numbers. Okay, so today we're focusing on perfect cubes. Okay, the ones to give us the nice answers. Okay, we'll worry about the other ones later. Okay, so perfect cube is probably what I should have called this. Okay, now let's talk about this. I'm going to do a few more just to show you how quickly these numbers are going to kind of spiral out of control. 6 to the 3rd power is 216. I got to break out my calculator, because I believe 216. 7 to the 3rd power is 343. 8 to the 3rd power is 512. 9 to the 3rd power, and you're already up by 1,000. Okay, so you're going to use a calculator, guys. There's not an algorithm. It's not like addition where you could just carry numbers over. It's not like division where you have some sort of method you can use to solve it. You're going to have to use a calculator. So first of all, I'm going to show you guys how to do this on a couple different calculators. So on your TI 84, I believe you press math, and it's this one right here, number 4. I'll scroll down. You could also just press number 4. So I said, what's the cube root of, again, 729? 729. It's going to tell us it's 9. Okay? So again, math, number 4, cube root of 512 is that. Now, I know most of you guys don't have one of these at home. That's okay. I would strongly suggest you guys go, if you guys go to Desmos, I know we use it mostly for graphing, but if you go to desmos.com, okay. If you go to Desmos, there is a 4-function scientific, right? There's a scientific calculator, and we have this, okay? If you want to do a cube root, this is you right here. So you press this button, it's going to let you enter a root there. So if there's square roots and there's cube roots, are there 4th roots and 5th roots and 6th roots? Absolutely, okay? Today, all you need to do, throw a 3 in there and start filling in numbers, okay? So if I say, what's the cube root of 8? It's going to tell me it's 2, okay? Don't clear this out. Just leave that 3 there, and you can punch in the other numbers, 64, 4, okay? What I do want to show you real quick is this. What happens when I put in a negative number? What's the cube root of negative 27? And it actually gives us an answer, okay? And that is one of the things we always have to keep in mind with cube roots, is that there are going to be negative answers. So if I said, hey, what's the cube root of negative, I don't know, 64? Well, we are allowed to have negative. Now, we couldn't have negative square roots, right? We couldn't do this. This was we needed a whole other set of imaginary numbers to do this, right? We needed a whole set of imaginary numbers to do this. Don't have to worry about that. In fact, all of your solutions will be real, because there is a number that multiplied by itself 3 times makes 64, and that's going to be negative 4, because negative 4 times negative 4 times negative 4, again, a negative times a negative is a positive times a negative. That will give us a negative answer, right? So we're allowed to take negative cube roots, okay? We weren't allowed to take negative square roots without using imaginary numbers. Totally fine to take negative cube roots, okay? So again, all you really need to know is take the cube root of this number and throw a negative in front of it, okay? So let's take a look at a couple of examples, and that's all you guys really need to know for today. I will leave this calculator up over here on one side, okay? It says, hey, what's the cube root of 8? Again, you go in there and you say, what's the cube root of 8? And it's going to tell you it's 2. What's the cube root of 27? Again, I think you guys should know at this point it's 3. Because the numbers get so big so fast, right? Answer show up on this side, answer is 3. They get so big so fast, they can only ask you so many numbers. What's the cube root of 1? 1, right? 1 times 1 times 1, okay? What's the cube root of 64? Again, 4 times 4 is 16, 16 times 4, okay? Cube root of 27 is 3, we know that one, okay? Cube root of 1,000. So what number times itself makes 1,000? It's 10, right? 10 times 10 is 100, and 100 times 10 is 1,000. Easy thing, if you have a cube root there, you see that there's 3 zeros there, okay? Divide that number, okay? 3 divided by 3 is 1, okay? So 1, 0. All right, what's cube root of 512? Again, things we should know at this point. Okay, and it's 8. Okay. Again, I think you guys can plug in the numbers. It's cube root of 343, no problem there. This one's, so again, negative 27. Well, again, the cube root of positive 27 was 3. The cube root of negative 27 is going to be negative 3. So again, legit negative answer, not an imaginary number, definitely a real number. Okay, cube root of negative 216. Negative 6, okay, and that's about it, guys. They can't ask, the only thing they can ask you is bigger, more complicated numbers. So I'm gonna say this right here is going to be for you guys. Take a look at those, and we'll talk about how this shows up when we graph them and all things like that over the next week or so, okay? So good luck. Let me know if you guys have questions. Thank you.